Welcome to ClickMyProject.com. Now we are going to discuss about the project exploring a fine-grained multi-scale method for cross-modal remote sensing image retrieval. Now we are going to discuss about the abstract of the process. Content-based image retrieval, that is the CBIR, is an approach of retrieving the similar images from a large image datasets. Recently, CBIR processes the new challenges in the categorization of the images. Hence, the different feature extraction technique have been proposed to overcome the problems. However, these methods suffer for the several shortcomings. This process contributes an image retrieval systems to extract the local features based on the feature extraction methods such as the scale-invariant feature transform, that is shortly known as the SIFT feature extraction. SIFT concentrates on the complete region of the images using the high fine parts of the features. The local features descriptor help in achieving the better results in large-scale image retrieval process. Hence, in this process, the feature stability is also a good performed, and then the classification also a good performed to retrieve the images, that is the exactly the relevant images from the datasets. So the final performance of the process will be evaluated by means of the retrieval rate by means of accuracy. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as the input image, pre-processing, feature extraction, classification, retrieval, and finally performance estimation. At first, the input image is taken from the dataset. The dataset is the satellite image datasets. So we have several combination of satellite images in the dataset. After getting any one image from the dataset, we just move to the second stage of the project, that is the pre-processing. In this pre-processing, we have two kinds of pre-processing step is there. One is the image resize, then the another one is the noise filtering if required. So image resize is done to resize the image in the size of 256 cross 256, which means the number of row will be the 256, the number of column will be the 256. After that, we have to remove the noisy pixels from the image by means of the noise removal method. After doing the pre-processing, we just move to the third stage of the project, that is the feature extraction. So in this feature extraction, we have considered the shape-based feature extraction by means of the SIFT feature extraction method. So by using this SIFT feature methods, we are extracting the statistical features from the images, then stored as a test feature. After extracting the features from the image, we just move to the classification step. In this classification step, the distance based classification is done to find out the minimum distance of the maximum matching point. So minimum distance in this sense, how much of minimum distance is achieved to classify the image will be the considered as an maximum matching. After doing the matching point, we just move to the retrieval part. In this retrieval part, the retrieval is done to retrieve the relevant images from the dataset. Finally, the performance is evaluated by means of the three performance parameters, that is the accuracy, sensitivity, and specificity. By these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the running procedure of the process. At first, open the Scilab 6.1.1 console. So this is the editor. So first of all, we have to select the main.sci. So right click in that one. You have to select the option execute in Scilab. So after the execution started, we have to select the dataset from the corresponding folder. After that, the process will be done one by one automatically. Once it was executed completely, I will explain the results one by one. Yeah. Now this is the input image we have taken from the dataset. So in this dataset, already we have discussed in the flow diagram, dataset having the lot of images which having the lot of category of satellite images. So among that, we have to select any one image from the dataset. Then those images shown in this figure 1. Now the figure 2 shows the resized image. Now the resolution of the resized image will be the low when compared with the input image. So the input image having the high resolutions. So in this one we have convert the resolution of the resized image into 256 cross 256, which means the number of row will be the 256, number of column will be the 256. Once we got the resized, we just move to the third step of the process. This is also a kind of a pre-processing. So in this pre-processing we are going to applying the filter. If the noise is present in the any pixels, means the filtering is applied to remove the noises present in the pixels. So after that we have to extract the features by means of the SIFT feature method. So here these are the features which is extracted from this image. The feature points are represented in the blue color star marks. After extracting the features, those values are saved as an test features. Then it will go for the classification step. During the classification, it was classified means the relevant matching informations will be gathered. Then the corresponding images will be shown in this figure window. Now totally around 10 images, around 25 images are extracted by this classification. After doing the retrieval, we just move to the final stage of the process, that is the performance estimation by means of the accuracy, sensitivity and specificity. If the overall accuracy is above 90 to 95%, means the efficiency of the classification is good. Thanks for watching this video.